Hello and welcome to today's video. In today's video, we are going to look at the nomenclature of coordinate or coordination complexes. So by looking at the nomenclature of coordinate complexes, what we want to do is we want to give names of these coordination complexes. For example, if they give us something like this, they give us something, okay, let me use, okay, we have something like this. How do we go about giving the name to this coordination complex? So this is what we're going to discuss in this lesson today. So I will quickly go into the steps. So the first step, which is step number 1, the first thing we have to do is we have to identify the ligands. So what are the ligands in the given coordination complex? Then, as we are trying to identify the ligands, we have to make sure that we write ligand names before the metal. So the rule is that we're supposed to write the name of the ligand first before we write the name of the metal. Now, there are a few rules that I would like us to pay attention to. I will say rule A, we have what we call anionic ligands. Anionic ligands. So when they say anionic ligands, this is when a ligand appears on the anion side of a complex. So when this happens, the ending or the suffix of these ligands ends with O. For example, this becomes a chloro. OH negative becomes hydroxyl. So this means that your ligand is on the anion side. C2O4 2 negative, this becomes oxalato. So we'll be familiar with these as we proceed. Then B is when your ligand is neutral. So what happens when you have a neutral ligand? So for these ones, we have spatial names, and these are H2O is known as aqua, NH3 is known as amine with double M, CO is known as carbonyl. So these are a few examples of neutral ligands. There is also NO, which is known as nitrosyl. Then, under the same, we can have a polydentate ligand, a ligand with more than 2 donor atoms. So usually here they keep the full name, nothing changes. The common example is ethylene diamine, where we use EN to represent ethylene diamine. The other one is oxalate, which is OX, oxalate. So those are examples of polydentate. But if it is found on the negative side, it becomes oxalato. That is rule number 1. So the important thing is name the ligand first. Excuse me. Name the ligand first. Then as you name the ligand, it's very important for you to understand, is my ligand on the anionic side? Is my ligand neutral? Or is my ligand a polydentate? Okay, let's go to rule number 2, or step 2. Arrange ligands in alphabetical order. What does this mean? So this is based on the ligand name. This is based on the ligand name and not the prefix. I will explain what this means. So here, what we're trying to say is ignore prefix such as, so you see di, you see a tri, you see a bis, you see a penta. So these are called prefix. So these do not affect the alphabetical order. So the alphabetical order is affected by the name of the ligand. Let's look at an example. For example, we have a complex which is cobalt and 3,4Cl2 positive. So in this complex, we have to identify the ligands. So this is a ligand and that is a ligand. So I have a ligand A, which is amine, and I have a ligand which is a chloro. Now when you look at these ligands, they have these sub numbers, which is a 4. So this one can be a tetraamine. Then this has got a 2, so it means a dichloro. So we are saying when we are trying to identify the ligand or following the alphabet, we're saying these prefixes don't really affect the naming. So here we'll consider the name. So this starts with letter A, and this starts with letter C. So in terms of naming, what is going to happen is we are going to name the amine first. So the amine will be named first, then the chloro will come second. So that is how the alphabet works. So it is not affected by the prefix. Let's move and look at 3. Indicate number of ligands. Indicate number of ligands. And to indicate these, you use the prefix. So I've mentioned this. So 2 means di, 3 means tri, 4 means tetra, 5 means penta, 6 means hexa. Then for polydentate ligands, we are going to encounter things or prefixes such as bis, tris, tetra, kis, penta, kis. Yeah, so we'll look at some of the complexes that have those names. Step 4. Step 4 now requires us to name the metal. So now, to name the metal, again, it's very important for you to know that a metal sometimes can be on the neutral side or can be on the cationic complex. So if a metal is neutral or cationic, they keep the name. So nothing is going to change on their name. So if Fe is iron, it's going to be called iron. If Cu is copper, it's going to be called copper. If Cl is called chromium, it's going to be called chromium. That's case A. Then case B, if your metal is on the anionic side, so it's part of the anionic complex, then the metal ends in those suffix. For example, Fe becomes ferret, Cu becomes cuprate, Au goat becomes aurate, tin becomes stanate, Ag argentum becomes argentate, Cl chromium becomes chromate. So this simply means that your metal is found on the negative side. So your metal is on the negative side. Then the name changes to ends with ATE. We'll look at some of the examples. Step number 5, you have to state the oxidation number or oxidation state of the metal. So this usually is shown in Roman numerals in brackets. So you see something like this. to show the oxidation state of a metal. So usually this helps us to balance, it helps us to balance the charge of the complex. 6, name of the counter ion, which is outside the coordination sphere. That is if it's present. If it's present. So for this one, you have to write the cation first, then the anion. The anion comes last. Then, once we understand these steps, it's also important to look at the common ligands that we'll find. So we have what we call neutral ligands. I'll just give a few examples. So we have H2O, which is known as aqua. We have NH3, which is known as amine. We have CO, which is known as carbonyl. We have NO, which is known as nitrosyl. These are the common neutral ligands. Then we have ligands that are anionic in nature. So these we have, the common one is the chloro, the bromo, hydroxo, for cyano. Then we have C, common bidentate ligands. So the C2O42 negative, which is oxalato. We have the EN, remember, the ethylene diamine, ethylene diamine. And then for the polydentate, the common one is the EDTA. It's a 4 negative. Acetato, ethylene diamine tetra acetate, yes, acetato. Then we also talked about ambidatant ligands. So the cyanato bonded the S, and then obviously the cyanato bonded with the N. Then we have the N O2, which is the nitro, if bonded with the nitrogen, then nitrito if bonded with the oxygen. So from there, I would like us to look at examples where we say name the following complexes. You give a few examples. So what could be the name of CONH3 6 and 3 positive? So here the first thing we have to identify is what ligands do we have. So the ligands we have here is the amine. Then how many are they? They are 6. So 6 means hexa. Then what metal do we have? It's a cobalt. Is it on the positive side or is it on the negative side? So it's on the positive side, so it maintains the name. Then the rule states that we have to mention the ligand first. So this becomes hexa amine, double M, hexa amine, then cobalt. Then what is the oxidation number? So the oxidation number is right there. So cobalt 3. That will be the name. Let me give another example. Let's say we have F E, then 6, for negative. So how do we name this one? So remember, it's on the negative side. As you can see, there's a negative here, so the entire compound is anionic in nature. So remember, when it's an anionic, then the metal ion is affected. So we have a cyano, because it's on the negative side. Then there are 6, which is hexa. Then the metal that we have here is ion, but it's on the negative side, so it becomes ferrite. Then we have to calculate the oxidation state. So the oxidation state becomes Fe plus 6. Cyano is negative, so the oxidation number is negative. Then the overall charge is negative 4. So this becomes Fe negative 6, negative 4, Fe negative 4 plus 6. So Fe, the oxidation number, is positive 2. So the name of this will be called hexacyanoferrite 2. Let's look at another example. C. Let's say we have CEN3, then 3 positive. What will be the name of this compound? You can pause the video and then try. So in terms of ligand, we have ethylene diamine. Then the metal, because it's on the positive side, so in terms of the metal, we maintain chromium. Then in terms of oxidation number, it's positive 3 according to what is given there. Now the tricky part is ethylene is a very complex compound. So whenever we are dealing with a complex compound, we cannot say triethylene, doesn't work. So here we use what we call a tris or trice. So this will be called trice. We close, then we say ethylene diamine. Then we mention the metal, which is chromium, then the oxidation number 3. Okay, let's look at another example. D. Let's say we have Cu, H2O, 4, then SO4. So here we have a ligand. So we have a ligand, which is H2O, which is known as aqua. Then there are 4. 4 means tetra. Then our complex, our metal is on the positive side. This is the negative side. So the metal maintains the name as copper. If we are to calculate the oxidation state, this is a neutral, so it's 0. So it's going to be Cu plus 0 plus sulfur is -2, then 0. So that becomes 2. So in terms of oxidation state, or oxidation number for copper, it's +2. So how do we name these? Starting by naming the ligand. So this will be called tetra aqua, then copper, oxidation number copper 2, then sulfate. Let's look at a more complex, which is E. How can we name E? We have CO, Cl, NO2, NH3, 4, then positive. So it's on the positive side. So here, if we were to calculate the oxidation number for cobalt, it has to give us that is neutral, that is negative, gives us a 3. So it's going to be cobalt plus chlorine is -1 plus this is nitro, this is -1. So then this is 0, then that is +1. So CO +2, no, sorry, negative. CO -2, then +1, so CO +2, so CO is +3. So we know the oxidation number is that. Then in terms of the ligands that we have, so we have a chloro, we have a nitro. If we take it that it's bonded to nitrogen, it's a nitro. Then we have this, and then we have the amine, which is 4. So in terms of alphabet, this comes first, that comes second, then nitro comes third. So this can be called, this can be called tetraamine, chloro, because there's only one, then nitro, cobalt, oxidation number is 3. So this is the first name. This can be the first name. The second name is where we consider that it's not bonded to nitrogen, but it's bonded to oxygen, which is going to be nitrito if it's bonded to oxygen. So therefore the name becomes tetra amine chloro nitrito, then cobalt 3. So for this one, it's all bonded. Then the first one is N bonded. All right. See you in the next video. And thanks for watching.